Hello, good morning, everyone. Thank you for taking out time and joining in early. So we see some more people joining the call, so we'll just start exactly in 2 minutes. Thank you for your patience and understanding. Hello, good morning, everyone. Thank you for taking out time to attend today's session. We are really excited to have you at the webinar. So with no further delay, let's get started. So I'll just give you a couple of moments for you to just go through the slide. It's just a safe harbor, the standard slide which we use in our presentations. So now let's move to the next slide. So as you all are aware, we've been talking about the contest for you to win some Amazon Echoes and some goodies by attendance and participation in the poll survey. So we just wanted to just take 1 minute to explain you the ground rules. So please do mention your full name and organization and official email address when you're taking up the survey. We will be having two parts to it. So first is the poll questions, which we will be asking, towards the end of the session. We would love to hear your feedback on that. And then after the session is over, then we'll be sending an email to you which has the survey link. Please do spare 2 minutes of your time, and we would love to hear your feedback on how the session went and how we could improve. And the Amazon and Echo and Autodesk branded goodies will be given to the participants who take part in the webinar, as well as in the poll questions and the survey. So please do ensure that you take part in that, and all the session and all the lucky draw winners will be published on the auindia.in/webinars website on 18th of December. So and you will also be receiving a communication on this through an email with the winners list, so you could look forward to it. And all the session and campaign related communication will be sent to you on the mail ID which you used for your registration. So please do keep a watch on that. So with that, now I would like to hand over the platform to Veera Pandian to take you through today's sessions. Veera, over to you.
Thank you, Avinash, and good morning, everyone. Welcome to this presentation on the advanced manufacturing tool sets available within Autodesk Product Design and Manufacturing Collection. So my name is Veera Pandian, and I'm a technical specialist for design and manufacturing at Autodesk, based out of New Delhi, India. As you all know by now, since you've been attending AU in the past 4 or 5 years, you all know that Autodesk offers a solution that spans across design and manufacturing. It includes the tools you need to design, simulate, analyze dimensional tolerances, nesting, CAM, and factory layout. All the data is stored and managed in a secure project. Best of all, this collection is available in a single affordable subscription, which is the Product Design and Manufacturing Collection. So it is this collection of technologies that enables our customers to connect on a single design platform, automate processes, and accelerate production. There are Four aspects on which these collections were built on. First, innovate, which you to, gives you to allows you to clear time for more innovation and take advantage of the tools that are purpose built to have a positive impact on the way you design and make products. So next is connect. By connect, I mean run your entire product development process on a single platform powered by professional grade 3D solid modeling, simulation, documentation, and multi-access CAM tools. Automate. Leverage data, artificial intelligence, and cloud technology to reduce iterations, optimize tolerances, solve complex engineering problems, and quickly create production-ready designs. And finally, the produce aspect. Enable smart manufacturing using familiar CAD interfaces, which is embedded within the CAD interface to automatically update design changes downstream and simplify machining workflows, reducing production time and waste. So today we are going to talk about how our customers can increase efficiency and reduce production costs using the advanced manufacturing tool sets within Autodesk Product Design and Manufacturing Collection. The focus of today's session will be on two such tool sets, which one is Inventor Nesting and another is Inventor Tolerance Analysis. Okay, so that is the agenda for today's webinar. So let's start with Inventor Nesting first. Okay, so if you've been a customer of ours using Product Design and Manufacturing Collection, we added this functionality in the last two releases. And so if you are on 2019 and beyond, you should be able to access this facility as a part of Product Design and Manufacturing Collection. Okay. So what is nesting? So nesting as such, this is Inventor Nesting is based on the automated true shape nesting, which the technology that we acquired a few years back, and then we packed most of the contents right into Inventor. Okay. So by true shape nesting, what I mean is you can create detailed nest to fit even more parts on a material. So if you are into sheet metal, okay, or even furniture, so it's not limited only to sheet metal. So anything that is flat in shape and needs to be cut from a bigger stock, which is a sheet again. So traditionally we have seen people using nesting tools, or if not, they use AutoCAD to lay out the profiles and make sure there is less material wastage. But that is a time consuming process. So it is ideal that we use tools like Inventor Nesting to automate this process, and also make sure find out what is the nesting efficiency, and subsequently take it to downstream manufacturing for doing a laser jet cutting or plasma cutting or whatever manufacturing machining process that you prefer to use. Okay, so true shape nesting, as I said, creates detailed nest to fit even more parts on a material. Since it nests part based on their actual shape, true shape nesting is able to pack parts together much more closely than the standard nesting, giving you better yield, better material yield, and thereby save money. Okay, so that is what true shape nesting is. Okay, and so not only it allows you to pattern efficiently the parts, the flat profiles that need to be cut, but it also allows you to find the efficiency of the nest, compare the efficiency between two different studies, okay, and the costs associated with it. Okay. And so Inventor Nesting, as I said, is directly embedded and running within Inventor. So it's a CAD embedded nesting software that, again, I said, help optimize yield from raw material. Since it works right inside Inventor, nesting studies can be created and then updated to reflect any changes to the design. Okay, so it is not a separate window wherein you have to again open the entire model and start the nesting study again. since it is CAD embedded. So any changes on the CAD model updates the nesting pattern layout which has been created, such as what you see on the bottom left figure is bunch of sheet profiles laid out on a sheet. So if it has, let's say, holes or something like that, and if we go back and suppress those holes or delete or hide that in Inventor, it updates the nesting study and to reflect the changes that you have made. Okay, and once this nesting is done, you see on the top right corner, it allows you to change the entire nest layout into a 3D model, okay, with the stock enveloped all around it, so which can be readily taken into tools like Inventor CAM, which is again a part of product design and manufacturing collection for cutting part generation. And all this happens again in a familiar interface. Okay. So, nesting not only reads 3D models and it automatically detects flat patterns, but you can also bring in DXFs, which are basically 2D drawings. If you have profiles created in AutoCAD, it can be taken added on to the nesting. Okay, something like a filler part or something similar to that. So nesting is going to use even the 2D profiles, not necessarily 3D, to lay out the nesting for you. Okay. So as I said, associativity between 3D modeling and the generated nest allows you to make sure that all changes are reflected and and uh, and taken care automatically. Okay. All the nesting layouts that are generated are also can also be exported as a DXF file if that is the format that you need to feed in into your CNC machine or the machine that is going to cut it. Okay, or you can use the 3D layout of the nest and generate the NC code using Inventor CAM. And naturally, since this nesting program is not it's a professional tool, it also gives you nesting reports, which are very useful to share with the manufacturer. Okay, now let's take a I will take you through a small example on how Inventor nesting works through this short video that I. Okay, on the screen, what you see is a CPU console, the enclosure, which is basically sheet metal. Okay, now it contains both sheet metal and non-sheet metal parts. Okay, and to start nest, if nesting is involved, we just say create nest, choose the template, which needs to be, in this case, I'm using a metric template. Okay, now automatically nesting is going to detect all the flat patterns as well as the material. Let me just roll it back a little bit to show you. Okay, I'm going to pause it here. Now you see the nesting, Inventor nesting is automatically detected. There are there are two kinds of material. One is steel mild and another is aluminum. Okay, but it is showing in three categories. Why? Because again, the steel mild is in two different thicknesses. So what nesting segregates is it segregates it based on the material and the thickness of the material. So effectively in this nesting study, it should generate three different sheets, okay, and lay out the flat profiles that needs to be cut. Okay, so let's move ahead. Okay, so all the automatic the flat patterns are automatically detected, and nesting, it brings it inside the nesting environment, and it lays it out in front of you. So these are the things that needs to be nested. The next thing is we just create a nesting properties, and you can see it has automatically taken the quantities as well. And here is where you have you can modify the orientations or the rotation, mirror, etc., to make sure you have the right orientation. Now, You can easily see what has been mirrored and what has been tilted by using the choices as you can see on the screen. So you know which has been modified. Okay, now and this the next thing is the packaging. Okay? Now when you in nesting, it allows you to define the packaging. Packaging is nothing but we define the sheet, the size of the sheet, okay, from which these on which this from which this pieces will be cut. Okay, so I have created a couple of packagings, as you can see, 2, 3, 4, etc. So I'm going with the stand, and I specify the job quantity, in this case 5 numbers. uh, and so you can specify the job quantity, and let's go ahead and do the nest. Okay. Now on the bottom side, okay, on the bottom left of your screen, you can see the nesting progress. Okay, now you see three things, as I said, because there is steel mild and there is aluminum, and again in steel mild you have 1 millimeter thickness and 0.5. So as we predicted, it is creating 3 sheets, so it is calculating the nest. Okay, and this is a multi-threading process. While this calculation is on, you are free to do other things. Okay, so once it calculates, then it creates the nest. Okay, as you can see on the screen. Okay, so there are three sheets. Okay, so let me pause it here. You see the top one is nest number 1, the middle one which is the second, and there's a third one. Okay, now you notice that we never specified how many sheets it should use. Okay, so Inventor Nesting automatically detects if that single sheet is not able to fit in all the components. It will automatically add an extra sheet and start placing the components. So in this case, the top one, if it's a steel mild 1 millimeter thickness, if it has more components, it's going to pull out the sheet based on the packaging that we defined and try to fit in as much as possible. Okay, and if there is something left out, it is going to add an additional sheet and then place the rest of the entity. So the top line is nest number 1. uh, specific material thickness, and so on and so forth. Let's zoom in a little bit and see how it has placed. And over here, we can see that this is not aligned properly. So what we can quickly go ahead and edit the properties, and we will stop the flipping and the rotation and make sure that these things are aligned. So quickly, you don't need to redraw just like otherwise, which you would do in AutoCAD. So just by a few clicks and specifying the orientation choices, and so you will be able to automatically align it. Okay. Now, so as I said, so this is all 3D model, but now I'm just going to show you the support for 2D profiles as well. Okay, so in here, what we are going to open is gusset, which is a profile, which is a DXF, and you can see it has come in automatically. We'll change the units in which we want it. Okay, and just bring it inside. Okay. So once this is inside, you just go to the, you can see nesting properties. You can see, we can assign the material for this gusset based on the packaging that we defined. Okay. And we can say, since it is a filler part, I'm just increasing the quantity to 10. So which means 10 of these profiles needs to be placed within the nest. So what we are doing here is we are creating another study, study number 2, which will have this filler part, which is a DXF profile. Okay, and later on, what we'll do is we'll see which one is the best nest by comparing efficiency, and then choose the right one to go ahead with manufacturing. So create, so specify the job quantity and say okay. So this is the profile, and you can see at the bottom left it is calculating the nest. Okay, now with this filler part, which is a 2D profile which has come in. Okay, so once this is done, Then we will compare the nest. First of all, we'll see how Inventor Nesting has used this profile and how is it placing. Is it using the gaps in between parts, or is it looking for open spaces in the stock? So it'll be clear once this finishes. All right, so now it is done. So let's zoom back in, and so what we'll do is I'm going to hide a few things and compare nest one of the study one and nest two of the study two. Okay, so here it is. So let's zoom in. Okay, okay. So on the top row is the first nest that we created. Okay, and the second row, the bottom row is where it's the second study with the nest which has this filler part, which is a DXF, and you can see that it has optimally placed these filler parts which needs to be cut as well, and you can see it has used the gap between a component as well. Okay, so optimum usage of materials, so that if this is not the case, then this whole chunk will be this piece of material is going to go as a waste. Okay, so now the next thing what we need to do is okay, okay, so let's go and check the comparison on the next study, and you can see the study one has about 64% efficiency, and let's see what the second study efficiency. So it's gone up to 71. So this is the nest that I'd probably go with. Okay. So you can have multiple studies created. Secondly, on the packaging, okay, you can add your own packaging, and in this size, so let's say the packaging size has to be very specific to the material that is available in the market. Okay, you cannot just simply give a 1 meter by 1 meter sheet, whereas in the market, if it is available as a 2 meter by 1 meter or whatever, so you need to specify that size to make sure that you don't have any problems when you order the stock material. Okay, so here is where I'm showing you how we can create the custom packaging based on the sizes in the market. So instead of 2 sheets, I would want to have a bigger sheet, let's say 2 by 1 meters, and I add that packaging. Then we go into the specific nest and assign that package that we created, which is package 5. Okay, and move it up the priority, and we say that this should be used rather than the earlier packaging. So based on this, when we run, ideally it should give us all these parts fitted in one single sheet, which is 2 meter by 1 meter, rather than 2 sheets of 1 meter by 1 meter. Okay, so let it calculate. So as I said, since this is a real-time, it's a multi-threading operation. So you can go ahead and do check other things. I'm not specifically doing anything here, just to show you how multi-threading works. So you need not wait until the thing is nesting is completed. Once it is completed, it's going to give you a message saying that it is done, and we accept that. And let's see how the new nesting layout has come. So there should be one sheet now. Okay, there you go. So there is one sheet of 2 by 1 meters wherein everything has been fitted. Okay, and see, now you see study one, which is the default thing that we had by that packaging at 1 by 1 meter, and the study two, we changed the packaging to 2 by 1 meters, and you can see how Inventor Nesting automatically has optimized the layout of the flat profiles. Okay, so the next thing what we'll do is we'll just try and take it to manufacturing. Let's choose this particular nest, and let's go ahead and export. One way is to take it as a DXF file, and so that if this is what you need, you can quickly change it to save it as a DXF file, open it inside Autodesk, and use the programs that you use inside Autodesk to send it to manufacturing. Okay, So the whole the nesting file which has come in inside of AutoCAD. Okay, so this is one way. Okay, and the second way is to convert that as a 3D model. Okay, which is a single click operation. Okay, we convert that as a 3D model. And what it does is it converts all the profile with the specific thickness into 3D, and you can also see a stock material that has been built all around it. It's in light yellow color. Okay. Once you're done, then use the CAM capability of product design and manufacturing collection again within Inventor. Okay. So let's set up this CAM and specify this as the stock point. Okay. And go ahead and choose the 2D profile that you want to cut. And there's something called curve width, which I want you to see. Curve width is nothing but what we tell in the packaging in Inventor Nesting, how much gap should be kept between two items. Here, currently we have a 1 mm gap. So when pieces are laid out, it will make sure there is a gap of 1 mm which is maintained. If you need that to be 2 mm, you can go ahead and change that. Okay, so we just come in and use that original curve width of 1 mm here, and select one of the planar faces. It'll automatically select all the faces so that which have to be machined. So your 2D profile is generated now, and all we need to do is just go ahead and simulate, and you can see the machine simulation happening, and then you can take an NC code output based on the machine that you're using. So this is how nesting works. Okay. So the next topic that we'll talk about is tolerance analysis. Okay. Okay. So we all know that tolerance analysis is required, especially when you are manufacturing parts and assembling them all together. That is where you need tolerances specified on each manufacturing part. So ideally, every part manufactured is the same size. Every part made is fitted into its assembly in the same way and performs the same, just as we designed it to. But in the real world, this simply is not the case. Materials, equipment, tooling, environment, operator inconsistency can all lead to slight variations, which happens. Okay. Individually, this might not be a problem on a per part, but incrementally, if all these variations can stack up, it can prevent the parts from fitting into their assemblies. And there is a threat of it becoming a scrap as well. So the question we want to address is, will the parts that make up an assembly always fit together? And is there an easy way to do this? Okay. So in a high volume manufacturing, it's easier to justify cost of working out the accumulating tolerances ahead of time, even if you have to do it by hand or in a spreadsheet. The cost is spread over the number of parts manufactured. With low volume manufacturing, justifying spending the time checking tolerances becomes much harder. Not just the cost, but the time it would take. Additional time in the design office delays parts going into manufacturing. Sadly, what we often try to shortcut the process by setting higher tolerances than what we need to, or we just don't think about it at all, and the problems get thrown over the wall to the manufacturing. So higher tolerances means the cost of manufacturing is higher because there are more surface finishing operations that needs to be done, which increases the cost. Lower tolerance or ignoring the tolerances altogether is also a risk, because you may end up realizing that most of the parts are not fitting together. So this can so overly high tolerance can increase the cost of the part. Say doubling the surface finish time doubles the cost, so on and so forth. More parts get scrapped for being out of tolerance. If you rely on manufacturing to work out the tolerances, they usually have to make a prototype, again, which means it is costing more money. And of course, if no one considers tolerance stack up at all, we are in a real trouble down the line, as I said. So that's where inventor tolerance analysis comes into play. Okay, so it is a subscription benefit for product design and manufacturing collection subscribers. So if you have this product design and manufacturing collection, so you should have access to tolerance analysis as well, which you can download and install from your Autodesk account. Okay, inventor tolerance analysis is designed to help inventor users make informed decisions while specifying manufacturing tolerances. It's a CAD embedded 1D tolerance analysis, which means it works. That all the dimensions have to be in linear fashion. It helps you understand the impact of mechanical fit and performance based on cumulative dimensional variation. So inventor tolerance analysis helps you to measure tolerance stack up in your 3D model to more accurately predict the level of tolerance you need to apply to the individual parts while ensuring that all parts will consistently fit together in the assembly. So let's take a look at an example on how this works. So what you're seeing on the screen is a gearbox, okay, and what we are interested here is to, so let's move it a little bit. And okay, now what we are interested to do is on the see that how this consider this spacer, okay, and the effect of it again and how it will fit together against the. So there is a, if you open the spacer, you can see there are some tolerant 3D GD&T annotations already specified. So inventor tolerance will consider all of it if you have already specified. If you have not specified, it's fine. You can specify it at a later stage as well. So tolerance analysis not only considers this, but it will also make sure that any changes that we do on the tolerances based on inside of inventor tolerance analysis also updates this. Okay. Okay. So it depends on how you assembled it. There are two ways you can get the objects. Okay. So this is a part built inside of Inventor, so it has been assembled accordingly. So there is there is a gear cover, there is a retention plate, and then which presses onto the spacer, then the worm gear. Okay, so this is the loop that we want to analyze. Okay, if the object is coming out of Inventor, then we'll do it in a different way. So let's go ahead and start tolerance analysis. Okay, I already have one study, so I'm going to minimize that. Let's start a new study. So it all starts with by saying create a new stackup on the top left. Okay, and the part of interest is the gap between the spacer and the gear housing. Okay, and then we place. So once we place the dimension, you can see inventor tolerance analysis has automatically detected the loop. Okay, so this is one of the unique features of tolerance analysis within Inventor. So this is the loop that we want to study. So here is where I told you, if the model was built in Inventor, then we assemble it accordingly, and then we make the loop detection automatic. Okay, but if this is not the case and you are bringing model from other 3D softwares, you know very well that Inventor can open all 3D models in their native format. So if you open a CATIA, NX, ProE, SolidWorks, whatever models, then the mating will not be there. But in that case, we can go ahead and manually define the faces that consist the loop. Okay. So let's go ahead. We select the loop from here, and on the right side, it should automatically capture all the tolerances of the objects that we created, as you can see on the right. Okay. Now, what it shows you immediately is a worst case scenario on the bottom. With okay, so let me scroll down to the bottom. Okay, and you should be able to see the stack. The objectives currently, the gap are 0 millimeters, and based on this current setting of tolerances, it says if you go with the minimum material condition, there is the probability is about minus 1.25 difference, and if you go with the maximum material condition, then there is a plus 1.25 mm, which ideally these two numbers, the stack up and the objective, should be closer. So let's go ahead and change the objective, because manufacturing with a zero is almost difficult. So let's go ahead and say we will manufacture with the 0.25 mm as a tolerance, okay, on the objective of the gap that we are trying to analyze. Okay. Now, the second thing that we want to know is, with this, again, it still shows there is a considerable amount of components which is in the red side that may not fit together. So first of all, we need to know which are the components in the stack up loop are contributing to this. Okay. So if you go down to the contributions, you can, it will clearly show you which are, so two components you can see, the spacer itself and the gear housing. These are contributing close to 40 and 40, around 80% for this tolerance stack up result. So let's go back and concentrate only on the spacer and the gear housing. Okay. So here is the gear housing. So inventor tolerance analysis allows you to change the tolerances. Okay. So all this we are doing to find out which is the best tolerance that we can use, wherein we can make sure all the parts will fit together. Now you can see by changing the dimensional tolerances to 0.2, you can see the stack up value has come to 0.95 from 1.25. Okay. And when I change here, it is also changing the tolerance on the gear housing in the model also. So I don't have to go back and change that. So the next thing is do it on the spacer. Okay. So the spacer, let's change it to 0.1. And still we can see the stack up is now reduced to 0.55 and object is still 0.25. Now this is based considering this is a worst case scenario, which means all the worst things can happen, just like Murphy's law, like all the wrong components will come into fitting and it will not fit. So rather than these checking the worst case scenario, it is very rare that an operator will pick all the wrong parts and try to fit in one assembly. So instead of looking for the worst case, okay, what we can do is we can go ahead and choose the root sum square option. So just which tells you what is the probability of that worst case happening. Okay, and here you can clearly says that the probability of that worst case happening is almost nil. Now you can see the stack up and the objective are almost same, 0.24 and 0.25. So this way you can make a sensible and logic decision on what is the right tolerance that you need to use on a component, thereby make sure that you're not increasing the production cost, or you're not ignoring the whole tolerance things together and leading on to scrap. So the next thing what we want to do is we need to share this with manufacturing shop floor people and let them know that we have done this analysis so that they don't need to do any kind of prototype. Okay, so tolerance analysis has a report generation option. So all we need to do is just go ahead and generate the report, give it a name, and it will quickly generate a proper report which can be shared with the manufacturer. Okay, so very useful tools. All these tools otherwise are also available separately in the market for an additional cost if you're using different softwares other than Autodesk. Okay, but since with product design and manufacturing collection, it is built right into it, because we know that these are all activities that you do within a manufacturing organization. Okay, so as we wrap up, I want to make a note that what we have discussed today is a set of very specific advanced manufacturing tool sets like sheet metal nesting and tolerance stack-up analysis. obviously there is much more to developing and manufacturing products and equipment. So with the product design and manufacturing collection, we address many other areas that can help you develop your products better. We spoke about nesting and tolerance tools inside Inventor, but it also included in the collection is advanced simulation for testing your designs. The simulation that is inside of the manufacturing collection is Nastran. Okay. Then we have 2.5 to 5 axis CAM capabilities and additional tools to help you create efficient factory layouts. So it's an end-to-end solution that all works right inside Inventor, along with complementary tools like AutoCAD and Vault for product data management software. So if you're interested in evaluating ways to improve your design and development process in any of these areas, we surely can help. Okay, so with that, thank you for listening. And now I open it up for Q&A. And Avinash, can you take the audience through the process Q&A?
Yes, sure. Thank you so much, Vida. So we are opening up the platform for Q&A. So if you have any questions, please do chat in the chat pod, which is visible to you on the right of your screen, and we should be able to help you answer the questions. So we're keeping it open. Please do type in all your questions in the chat pod, and once the Q&A session is over, we will then move on to the poll questions.
So all the attendees on this call, you will not be able to ask a question over the GoToMeeting line. So if you have a question, please use the chat area to type in your question, and we'll do our best to answer it. Okay, so I can see a lot of questions come in. Let me see.
Question: we are looking for someone who can
Yeah,
help us with
okay.
Dynamo inside.
Okay, so it's all there in the questions panel, Avinash. Okay, so we are looking. So is there a possibility? So there is a question from one person. It says, is there a possibility to nest for 3D geometry? Example, optimize number of screws from a given size rectangle bar stock of alloys or alloy steel. No, so this is so this nesting is based on 3D, but it is for sheet metal, all flat profiles. So it is ultimately things that need to be cut out from a sheet. So it can be a um, sheet metal product. It can be wood or anything of the sort. That is what we support. Do we have a 3D tolerance stack analysis? Now, as I said, this inventor tolerance and the analysis is a 1D tolerance stack analysis right now, but what it is going to, it's not a 3D tolerance stack. So if we have loops going up in a different axes, then it is just going to warn you, but it's not going to solve that for you, because this is a 1D tolerance analysis. Okay. There's another question which says, is the same module available in Fusion 360? Okay, what I understand is there is some bit of if you see, if you're asking about same module considering nesting as well as tolerance analysis no, but nesting yes, to some extent it's going to be available in Fusion 360. And there is another question which says need help with I believe Dynamo and SubD. These are two different things. Dynamo comes into the AEC industry, and SubD is subdivisional modeling, if I guess. So I need some more clarity on that. How do you decide overall plate cutting size, or it comes to automatically? Okay, so in the nesting, see, the plate cutting size is normally what I would say is the stock size that is available in the market. Okay. So that is something, that is what I said, you define it as a packaging. So the packaging has to be defined first, based on which the inventor nesting will lay out all the flat patterns. What is the aim and right of the project? So somebody has a question about Project Dynamo. So this is not the forum for that. So we will be running a series of webinars on AEC topics. So I would suggest that that is the forum to ask this question. Is it possible to, so there's another question which says, is it possible to list down all the dimension with tolerance on it in the IDW or DWG file? Yes, it is absolutely possible. So there's another question which says, is it possible to break the solid component imported from IGS file? Or I don't understand what you mean by break. If you're meaning to split, yes, you can split.
So we just have 1 minute left for
Yeah.
your last set of questions.
So,
After
yeah,
which,
so,
if you have any questions, the next
so,
1 minute you can type. After that, we'll move on to poll.
yeah.
Thank you.
So Avinash, these questions can be made available to us at a later time as well, so we can respond back to the people who are asking them.
Sure, we can. Yes.
Yeah. So, so I may not be able to answer all the questions. I'm just picking questions randomly, which are interesting, and it doesn't mean we are not going to answer the other questions. So what we'll do is these questions will be made available to us, and we have your name and your email address. So we will. So for those questions which I haven't answered, I am going to respond on a one-on-one mail. Okay, so somebody asked, this is software bundle with PD and M collection? Yes, absolutely it is. Okay. So with that, I'm just closing the Q&A session. For people who are expecting answers, just make sure that you will get your answers in the form of an email if you have shared your right email with us. Okay. So if you haven't shared, just find a way from the survey link to share it with us. Okay. So Avinash, I'm going to close the panel, poll panel right now. Okay,
Yeah,
and
we can launch the.
okay, so we do the poll questions now.
Yes, let's get started with the poll questions.
Okay, so here is your first poll question.
So the first question is displayed by Veera. Please do select your answers.
Yeah, so we'll give you about 5 to 10 seconds to answer it. Okay, and we move on to the next question. All right, so we'll move on to the next poll question, which is, so the next poll question should be on your screen. Talks about how do you relate the workflows presented in it? Is it useful to you, or if it is not complete, it's not useful at all, then let us know. You may be in the wrong webinar, or you may want to know. I saw a couple of questions on AEC section, so we will direct you to the right webinars. All right, so let me move to the next poll question. So it says, with relevance to the work that you're doing in your organization, was the contents of the webinar today relevant to you? All right, thank you very much. Let me move to the last question. So if you see interest in it, and if you want any of our representatives to get in touch with you to know more about what we spoke today, please let us know. All right, thank you. That is the end of the poll. And Vinash, over to you.
Yeah, thank you, Veera. So, attendees, please do note that you will receive a survey link out immediately after this webinar, as well as an email. So please do take out time and answer the questions, and do wait for us to announce the lucky draw winners on the website on the 18th of December. Thank you so much for taking out time, and have a good day.
Thank you, everyone.
Thank you. Thank you.